Okay, let's get started. Good morning to the audience. Hi on YouTube. So this is recorded. Welcome to my talk. I'm Jonas, working for Eclipse. The advantage for you today is this is about an FAQ about Eclipse topics. So if you have any question at any time, just interrupt me. I'm sure we have the time to answer all your questions if you have any. So we can make this more interactive today if you like to. Let me give you a short background of this talk. I'm working at Eclipse in Munich, and we as a company are focused to provide services around technology. And as the name implies, many of those technologies are from the Eclipse ecosystem. So we are focused to support our customers with training, with development support, with sponsored development to apply the technologies. So we are in contact a lot with people who get started with Eclipse initially, like from selecting the framework, for making the choice whether they want to use it or not, up to the first project, the setup, and all this stuff. And along this way, we experienced that there is quite a large number of recurring questions that almost everybody has who gets in touch with Eclipse. So the goal of this talk, when I submitted it, was to do a collection of those frequently asked questions and to provide initial answers to those questions. There are two things that I realized while preparing the talk. First, even 50 minutes are not enough to answer all questions. So this is really like the most frequent one. Of course, there's more. And second, for some of the questions, it's not possible to answer them completely, like with all technical details. Solution for both problems is actually, today in the talk, I would like to give some initial overview to get an initial understanding. However, in parallel, I also prepared a textual version of this talk, providing much more detailed answers to all the questions. And I will provide the link on the last slide. So if you stay for the whole talk, you get the link. And then you can actually read more in detail, especially about the more technical questions. Okay, and last disclaimer before I get started. I tried to order the questions a little bit top-down, meaning the most general questions first, and then we go a little bit more into detail about some technologies. However, there's no really good order in which I will present the questions, basically question by question. Okay, and questions I want to talk about today are like, what is Eclipse, like very high level, when to use Eclipse, obviously, and when not to. What is OSGi? How to build an Eclipse application? Is it really for free? Can you use it in your project, or do you have to care about licenses? And finally, pretty common question is, should I go for Eclipse 3.x or 4.x, or what's the difference? Okay, so let's start with the question heading in the direction, what is Eclipse? When we talk about the question, what is Eclipse, it makes sense to have a look where Eclipse comes from, because that helps a lot to understand the different building blocks that the Eclipse ecosystem consists of, and get a better understanding why actually all those technologies are there and the Eclipse Foundation and so on. As you can see, I have a timeline, and compared to the keynote yesterday, I really have numbers which mean something. So it starts in 2000 and ends somewhere in 2017. So the origin of Eclipse was done by IBM. It was an internal IBM project, and the original idea was to develop a tool platform. Tool platform means a framework which you can use to create tools which typically are meant for developers. Tools like a Java IDE, a JavaScript IDE, a C++ IDE, and whatever. So the common parts of all those tools are the tools platform. And IBM wanted to achieve two goals with this platform. First, they wanted to reuse common functionality. That's pretty obvious. So because many tools have common features, for example, SCM integration, like Git or back then SVN, so that you don't have to re-implement all this stuff. And second, better integration for the end user, because back then, like in the late 90s, more and more projects involved several technology in parallel. So you needed a tool which was capable to modify XML, JavaScript, and Java at the same time. And by having a common platform, you could easily integrate those tools together. So those were the main two drivers why they created this platform. Initially, it was not open source. It was an internal project. Now, the second thing which they started to do is if you have ever built a framework, you probably know it's always a good idea to have at least one use case for the framework, meaning if you build a tool platform, you should have at least one tool which is based on that. And the first big tool that they based on it is a Java IDE. That's the Java IDE that we still use today in a newer version, and that's, I would say, the most prominent thing that Eclipse is. It is a Java IDE. However, in detail, it's actually a Java IDE which is based on a tool platform. So if you download Eclipse today from the download site, the Java IDE is what you typically get, except if you download any other language support like C++ or PHP. Another connection between the Java IDE and the tool platform is that pretty much from the beginning, of course not from day one, but pretty early, IBM used the Java IDE to work on the tool platform too, because all this stuff is written in Java. So to develop the tool platform and also the IDE itself, you need some tooling, and that was also provided by the IDE itself. So Eclipse bootstraps it pretty much from the beginning. Okay, so this was the origin of Eclipse. Now there was another strategic decision done by IBM. What they wanted to do with their tool platform is build up an ecosystem of tools, and they wanted other vendors to develop things based on their platform too. Reason for that is they wanted to strengthen the tool platform, and the idea was that if many people provide tools, then it's more attractive for the users, and they can also save cost because other people might contribute too. So they decided to open source the platform and also the IDE. Initially, that was only for a short time. They had a consortium of several companies who wanted to work on this, but pretty soon they founded the Eclipse Foundation, which is an independent organization, and up to today, the role of the Eclipse Foundation is to define the rules, the processes, and the infrastructure to work on the Eclipse platform. So that's the role of the Eclipse Foundation. It's driven by its members. IBM still has a big role in that, but they gave up the core control of the project. Which was an important step because then it was even more attractive for other companies to contribute something to this platform. So almost immediately after the tool platform has been released, people started to use it and to create plugins and tools. Difference between plugins and tools would be if you create a plugin, that's something that you add to an existing product, for example, the Java IDE. So you could, for example, add support for check style or find bugs to the existing Java IDE, so that's a plugin. However, it's also possible to create a completely dedicated tool, like the C++ tooling based on Eclipse has nothing to do with the JDT, with the Java development tools. And there's also a tool for PHP, for example. And there is a number of commercial tools provided by different companies for their own languages or for their own hardware devices or whatever, also based on the tool platform. So far, everything is pretty much focused on development tooling. However, people who were developing plugins and tools back then, they pretty much liked all the concepts provided by the platform, and they wanted to use the same concepts in their business applications too. The concepts I'm talking about is, for example, perspectives, these views that you can drag around, the toolbars, and all this stuff. So initially, this was pretty hacky. However, with version 3.0, which was released in 2005, the core team introduced something that we call RCP, that stands for Rich Client Platform. And the background of this is actually they took the existing tool platform and separated it in two pieces. One piece was RCP, which contains all framework components that you can use in any kind of application. Things like the perspective, views, all this stuff. And the second piece is still the tool platform, which contains stuff that you typically need in development tools. For example, SCM support, resources processing, or something like that. So that was the origin of RTP, meaning Eclipse as a platform for general purpose applications. And immediately in parallel, some frameworks were arising in the Eclipse ecosystem, which also support general purpose applications. So for example, there are frameworks to build form-based UIs, there are frameworks to single source a desktop application with a web application and for communication and so on. So there are many runtime frameworks in the Eclipse world too, which do not really have anything to do with the IDE anymore. Finally, last thing on this slide is in around 2010, a new major version of RCP has been released, which we call the Eclipse 4 application platform. Actually, it simplifies the API of RCP and it makes it even more flexible to create general purpose application based on Eclipse. It doesn't really affect the tool platform or IDE so much. This only affects applications which have nothing to do with development use cases. Okay, so long story short, now what are the concrete use cases that you can use Eclipse technology for? I will start at the bottom and then go up. So first thing is Java application based on JVM. This has nothing to do with Eclipse. This is like the standard without Eclipse. Now, the underlying technology of Eclipse that you can use, or the first technology in the stack is OSGi. OSGi is a module system. I will talk about that more in detail later. And you can build an OSGi application without using any other parts of Eclipse. You typically do that if you have high or if you have a lot of requirements for modularity, which I would say is typically done in the embedded area only. If you build something on Eclipse, you automatically use OSGi. I haven't seen that many applications on desktops which only use OSGi. It's more valid in the embedded area, I would say. Now, based on OSGi, we have the rich client platform, RCP, or now the new version, the Eclipse 4 application platform, a platform which supports general purpose applications. And if you base on this platform, the thing that you build is called an RCP application. That's done if you want to build, let's say, an ERP system, a tool for your finance, for insurances, or whatever, which has nothing to do with development. Then we have the tool platform. You can base on that. You do that if you want to build your custom tool. So let's assume you're a chip vendor and you want to deliver some tooling to program your chips to your customers. You could use this and then base your tool on that. And finally, you can create plugins for the existing products. At Eclipse, for example, you can create a plugin for the Java IDE, and thereby you extend the existing tool with your new functionality. So those are, in a nutshell, the different use cases for Eclipse. Now, what is the reason to use the Eclipse platform? What's the motivation to do that? First, very important thing is modularity. Eclipse is very modular, so you can use the existing pieces and put them together exactly as you wish. And that makes it very convenient to create a product which exactly contains the features that you want. And you can extend almost everything there. So if you want to customize and reuse, then Eclipse is a good choice. Modularity also helps to build up pretty complex applications. If you want to build an MP3 player, then Eclipse is much too heavyweight, but if you create a business application which is deployed for 10 years or more and contains, I don't know, 10,000 use cases, then modularity becomes pretty important. Key strengths is that there are a lot of frameworks which you can reuse. So typically it's much more efficient to build something based on Eclipse if you find the right frameworks which support your work. That will save tremendous efforts. For a good example is the modeling area. There are several frameworks which allow you to generate part of your application, so you don't have to write or manually have to write big parts of your application again, anymore. Maturity. Eclipse is now there for almost 17 years. So you might think it's old. However, It's still actively developed, so there are still committers and maintaining the stuff and providing new features. If you want to build something which lasts for more than, let's say, 2 or 3 years, you need to look for frameworks which have a certain life cycle. If we look at the web area, there are many JavaScript frameworks which come and go after 2 or 3 years, which is pretty bad if you want to build a product which lasts longer than that. While Eclipse has been there for a very long time, and it remains to be there, and as it is all open source, it's also possible to join the maintenance. And that's the last point. Eclipse has a very commercial-friendly open source license. The license explicitly allows you to create commercial products on it. You can actually download Eclipse, put some tiny bit on it, and then sell it, if you like. Second interesting thing is that all Eclipse projects have a process to check the intellectual properties. That means if you use an Eclipse project, you can be pretty sure that it doesn't violate the patents or the rights of anybody else. While if you just download any library from GitHub, there's no check that this is actually legal. Anybody could put any code literally there. Okay, so now that we talked about when to use the Eclipse platform, what are typical use cases today? That has evolved over time. So I'm really talking about today because we see a lot of projects that we support. So we have quite some overview what's currently done or started with Eclipse. Big area is still IDE plugins, meaning you want a new feature in the Java IDE or in the C++ IDE, you can create a plugin. And custom tools, meaning a company needs a custom tools to support, let's say, a custom language or a subset of C++ or a custom hardware device or something. They still like to use Eclipse because it's very flexible, it's for free, they can download it, they can add some customization, add a completely custom branding, and then sell this to their customer, or they just give it, provide it along with devices or whatever. Then there is a very big area, I would say that's probably the most active area at Eclipse in our days. That's an area that I call modeling or data-centric tools. Those tools, there are even 2 areas in modeling tools. One area is modeling tools which are somehow related to software engineering. So things like UML tools or any graphical or textual language. So this is a very active area. However, it doesn't always have to do something with software development because the problems, if you describe, let's say, a software or on the other side, let's say, a contract for an insurance, at the end of the day, pretty much the same. The common scheme is that users of the tools need to enter data, complex data, and they require features like validation, form-based UIs, maybe graphical UIs, versioning of the models, and all this stuff. Migration of models in case they're changed. And there are frameworks for most of those tasks, which makes it very, very efficient to create tools based on Eclipse, which have a high focus on entering data and especially complex data. ERP systems are another part of this. So there are a lot of ERP systems based on Eclipse. I would say currently the most active area are engineering companies who produce some devices and they need to configure those devices in an application. And then finally, business applications. So things like ERP system or analyze software. I would say this area is not so active anymore because those applications are nowadays often done as web applications, like classical business applications. However, another area where Eclipse is still very active is control center-like applications. So, for example, applications which control trains or airports, or what we see here is actually an application written by NASA, which controls the Mars rovers. This still runs on JPL in Los Angeles. One of the first big RCP application was written by NASA to control the Pathfinder missions. Okay, so now we leave a little bit the high level and dive into the first concrete question. And the question is, what is OSGi? There are two more terms related to that, bundles and features. So what are those three things? OSGi is a module system for Java. And the main idea is, instead of having one big Java application where you put everything on the class path and then deploy the whole chunk, you can split your application into several or into an arbitrary number of independent components, like 1, 2, 3. Those components in OSGi are called bundle. So that's the name for one component or for one module. And what you can do in OSGi is you can select an arbitrary number of bundles, group them together, and then start this as an application. You can even deploy new bundles during runtime. So if you decide I want a new feature in that application, you can just put bundle 4 in, or you could take it out again. Of course, this is a little bit more complex in practice because bundles obviously need some dependencies among each other. You cannot independently deploy anything. However, OSGi provides a very good way to describe those dependencies. And that makes it pretty convenient and manageable to create applications which literally consist of thousands of bundles. Speaking about the number of bundles, it would be very hard to really manage an application on the bundle level if you have several hundreds or thousands of bundles, and that's where a feature comes into place. A feature is nothing else than a group of bundles. And this helps the people who configure it. So typically, what frameworks do, they group a certain consistent set of bundles together, and then the user or the maintainer of an application can decide, I want to pull in that particular feature, which, for example, contains 10 bundles, which adds a consistent set of functionality to an application then. If you ever use the IDE to install something new, like JIT support or find bugs or whatever, you typically select features, not bundles. Okay, next question is how to define APIs in OSGi, or what is the role of APIs in OSGi? When we think about this scenario, we can split our application into several bundles. You might conclude that in this scenario, it's pretty important how those different bundles talk to each other. Because if you want to do something like this, like removing a bundle or replacing it with a new version, then the API which is used for the communication between bundles becomes very important. So that's why OSGi supports API definition. In this scenario, we have bundle 1 and bundle 2, and bundle 2 consists of 4 classes, like Java classes, and we have a caller here which calls all those 4 classes. This is actually bad, because now if we want to replace bundle 2 with a new version, the new version has to provide exactly those classes, and those classes cannot be changed, meaning the signature cannot be changed. Otherwise, we would have to adapt the caller too. Now, what OSGi provides is you can define so-called API packages. Those are the packages which are visible to other bundles, and only those. And the typical scheme is that you have a very small, or as small as possible, API containing interfaces, and now the caller is only allowed to access this particular Java package, while all the other classes reside in an internal package, so they cannot be accessed at all. Now the advantage is if you work on bundle 2, you can do whatever you want in those classes as long as you don't touch the interface. All callers remain unaffected. Side comment on this. This might sound familiar to you if you have attended a Java 9 talk, like about Java modules. Now, if you wonder about the difference between OSGi and Java 9, there are some difference in some details, but although this might sound arrogant, the main difference is that OSGi has been there for 12 years now in a working version. It's deployed in many, many projects. It works very well in practice, while Java modules are not even there yet. That's the main difference. And Java 9 tries to simplify some parts, which are actually, I would say, a little bit more complex in OSGi, although you could argue that this simplification is actually too much to really cover the use cases in a real project. But let's see how that turns out for Java 9 modules. Okay, next topic is a confusion about versions, which has started with the release of Eclipse 4, the first version of Eclipse 4 was released in 2012, actually. And since then, there are two different APIs for the rich client platform. Now, let's look at the change a little bit more in detail. What we see here is a typical 3.x application. And down here, we see the 5 core technologies that are typically used by every Eclipse RCP application. There are typically more, but those are really the core ones. That's the Eclipse runtime. I will not go into detail about that. That's OSGi. And that's JFace and SWT. JFace and SWT are the UI toolkit provided by Eclipse, so pretty much like Swing. And then in the middle, we have one bundle, which is called the Workbench. That's org Eclipse UI. The features that this one provides are perspectives, views, editors, toolbars, and menus. All this stuff that you know from the Eclipse IDE, and which actually creates the structure of your application. Now, Eclipse 4 has changed this. So the API here has been completely reworked. Now, what you can actually do today is you can either use the old API for your Workbench contributions or the new one. Now, the good news is if you have an existing application, there is a compatibility layer, meaning every Eclipse 4 version that you download has a layer which you can use in between the new API. And this layer provides the old API. What it actually does is, if you have an existing application which has used the 3.x API before, you can use this layer, and this layer will transfer all calls to the new API. That basically means you don't have to change something. It's like a legacy wrapper. Now, there are 3 choices that you can use in the future to write Eclipse applications. Number 1 is you stick with an old version, for example 3.8, and use the old API. Number 2 is you use the new API with the latest version. Number 3 is you use the latest version but the old API. Those 3 choices. Now, what should you do? You should not go for 3.x anymore, meaning you should not use old versions because they are not maintained anymore, and you will not get any bug fixes. So if you have an existing application based on 3.x, you should migrate to a new 4.x one using the compat layer. So choices are actually between pure Eclipse 4 and compat layer. Those are the 2 valid choices. It's worth mentioning that most of the existing IDE-related stuff still uses the 3.x API, meaning the IDE itself, for example, runs on the compatibility layer. And that's the main reason why the compatibility layer will not go away anytime soon. So it's not a temporary thing, it's really a published API. So to decide between this and this, the easiest or the only choice actually is to look at the existing frameworks and bundles that you use in your application. That includes things that you have written yourself. If you have a lot of stuff which is 3.x based, third-party libraries and your own, I would not migrate to pure Eclipse 4 just for the sake of doing it. I would stay on the compat layer. If you have only a few 3.x based things, meaning if your own application is pretty small or only does a few calls to the Workbench API, I would evaluate whether it makes sense to migrate to the new API. And if you have nothing 3.x based, then I would go for the new API. It's that simple. That means However, that means if you write a tool, meaning, for example, if you extend CDT or JDT, it's very likely that you will use the old API because all this stuff is based on 3.x. Okay, next question. Now we come to like more short questions which are kind of mixed together. How to build Eclipse applications. What you do is, so there have been several build technologies in the past over the years. First one was PDE Builder, then there was Buckminster, and the latest one I would say is Maven Tycho. The winner is Maven Tycho. That's very clear. So don't look at any other, at least that's my personal recommendation. Don't look at anything else. Use Maven Tycho. Tycho is a plugin for Maven, which provides two features or two new features for Maven. The first one is that you can that it can build Eclipse-specific artifacts, and those artifacts are bundles, like the modules, features, and products. Product is at the end of the day the configuration if you really want to have a runnable application and you want to configure which bundles and features are in there. And Maven Tycho allows to build all those three things. The second thing that Maven Tycho can do, it can read the meta information provided by OSGi. That's important because in Maven, for example, you can define a version for every module in the POM file. However, in OSGi, every bundle already has a version, and to not duplicate this information, Tycho will actually process the OSGi information first, so you don't have to duplicate that in the POM file. Simple answer to this question is Maven Tycho. There are tons of tutorials out there. That's the way to go. Another question which leads to a lot of confusion for Eclipse beginners typically is the concept of a target platform. So let me explain that more in detail. When you develop a Eclipse application, what you do is you use typically the Eclipse IDE to work on bundles. Those bundles are located in your workspace, meaning you have the sources on your computer, and now you can use the compiler to compile this and then start an application which you see on screen. This application will then contain your bundle. However, your bundle might require an existing bundle, meaning a third-party library, typically from the Eclipse ecosystem. So this bundle has to come from somewhere. And that's exactly, like the location where this comes from, that's exactly what a target platform is. So for every workspace that you work on, you define a target platform, which is the location where all the dependencies are resolved from. Now, in the simplest version, and that's technically actually what it is at the end of the day, the target platform is a directory in which locates binaries, meaning jar files of all the bundles that you depend on. Now, there is some confusion because if you download Eclipse the first time and you just create a new bundle and get started with your work, you can start this bundle without even setting up any target platform. And that's also the reason why many projects never actually really set up a target platform. And the reason for that is if you would set up a target platform, that would actually mean is that you go to eclipse.org, you select the frameworks that you want to use in your product, you put them in a directory, and then you depend on them. However, if you download the Eclipse IDE, the Eclipse IDE itself also contains a lot of Eclipse technology. It typically contains most of the plugins that you will use in your running application too, because it's based on the same technology. And that's why the default of every Eclipse IDE is that this target platform is configured to point to an Eclipse installation, and this Eclipse installation then points to the IDE itself. That actually means that the IDE uses itself for compiling. This is a good default because you can download the IDE and just get started. So you don't have to download the same technology again. However, if we really build something based on Eclipse, I would recommend to decouple this, because otherwise you always have to use the same version as an IDE as for your running platform. This is typically not a good idea, because for the IDE you typically always want to use the latest, while for your running application you might not upgrade for every new release, because you need to test that properly. Speaking about testing, so how to test Eclipse applications? Plain answer is JUnit can be used as for any other Java application. There is a special JUnit test supported by Eclipse, which is called a JUnit plugin test. The difference to a plain JUnit test is that it also fires up an OSGi environment, so you can work with bundles and you can test dependencies between bundles. That's the difference. However, most stuff is still tested in JUnit. There's one framework to test SWT applications within JUnit tests called SWT-bot. This allows to headlessly trigger UI interactions. So for example, you can test dialogues by writing, I don't know, now I want to press a button, now I want to check that the window is closed, and so on. Plus, there are two system test tools which are focused on RCP. One is called RCP-TT, RCP testing tool, and Jubular. So those are more meant for system or acceptance test of the complete product. So they allow recording or defining test scenarios which are then executed on the full application. Okay, so next question is, which technologies should you use? Which technologies should you consider? UI technologies, most of the stuff is done in SWT and JFace. That's the standard UI toolkit, although there is also support for JavaFX. So if you need to write something very shiny, or if you need to style your application very extensively, you might want to consider JavaFX as an alternative. For the browser, there's also a solution called RAP, that's Remote Application Platform, that allows you to single source a desktop application to a web application. That basically means you only have to write your UI once, and then you can run it on the desktop and in the browser in parallel. Pretty interesting if you have that use case, or for example, if you have a fat client providing a lot of features, but you want to provide parts of those features in a browser too. If you want to develop IDE plugins or a custom tool, the most prominent frameworks are definitely the Java development tools, JDT, and the C development tools. There's quite a number of other existing IDEs too for different languages like PHP or JavaScript. Plus, there is a framework to develop language support for your custom language. That's called Xtext. So if you need to define code editor, syntax highlighting, and autocompletion for your own language, then you should definitely have a look at Xtext, because it can generate most of this feature just by defining a grammar for your language. Pretty extensive feature set. There is a new or pretty new project at Eclipse called Eclipse-based. That's a cloud IDE. I will not go too much in detail about Eclipse-based because there's a talk directly after my talk in the same room about it. In a nutshell, it provides a cloud IDE, so you can modify the code in the browser. Plus, it provides a server which can actually host runtime. In those runtime, you can execute and compile your code. The advantage of that is that you can pass the development environment for a product pretty efficiently to somebody else. So if you develop something which requires a lot of setup, you can do this setup on the server and then just duplicate it for every team member. So a little bit like a virtual machine in the browser. If you develop modeling or data-centric tools, most important framework is EMF, stands for Eclipse Modeling Framework. That's a very pragmatic modeling framework which allows you to generate entity classes. The idea is that you define the data of your application in an abstract way, meaning you don't have to type in get name, set first name, and all those attributes manually, but you can just define it in a simple language, and then you generate the Java classes which hold the data from that. Saves a lot of effort and enables the use of many other tools. If you want to do something graphical related to UML, I would have a look at Papyrus. If you want to have a custom graphical editor, then GMF and Sirius are the frameworks to go. So those frameworks make it very efficient to produce anything like that. If you want to modify your data in a form-based UI, meaning you have attributes, layouts, complex tables, anything form-based, then have a look at EMF forms. Pretty active framework. If you want to compare things, meaning if you have two states of your data and you want to show the user the difference between both, pretty complex problem to solve. Luckily, there is a framework which takes care of that and provides a lot of features out of the box. And there's much more in the EMF area, much more that I couldn't even demonstrate today. As you might probably guess already from those three frameworks, the modeling or data-centric area in Eclipse is currently the most active one. So complex data-centric tools, if you have something like that, then Eclipse is your home. And many companies are actively using those frameworks and also contributing new features to that. Okay, so coming to the last question, how to select technologies. That's also related to the question, or that will also include the question, is it really for free? So can I just use it, or what do I have to do as a user to use those technologies? So from a license point of view, all those technologies are for free. So you can download them, you can build your own stuff, and then you can sell it. No problem. That's explicitly allowed. However, how to select the right technologies for you? Because if you get started with Eclipse, you will experience that there are really a lot of projects. I think at the moment there are 330 projects at Eclipse, and you have to somehow choose the technologies that you really want to do. First, that's a very generic advice, but take time for the decisions, because if you include something in your product, your code will adapt to that. And if you have to take it out later on, that might cost you additional effort. So I would rather invest in an initial evaluation than later have the effort to take it out again. However, I would not reinvent the wheel. If you have to, for example, compare two models, have a look at EMF compare. If it's not perfect for your use case, I would rather try to adapt it than completely re-implementing something custom, because we typically underestimate the effort of re-implementing something from scratch. I would start with looking at articles, blogs, and the website. That gives you some impression what the framework does, what are the people behind this framework, and how active is it. Most efficient way is definitely to visit events where you can meet the people behind the frameworks, like EclipseCon, demo camps, other events. Just check out eclipse.org. There's a list of ongoing events. And then talk to the people. Probably you can find out more about the framework during a 5 minutes talk with some of the developers than 1 month of research. Because talking to the people lets you understand who are the people behind them, why do they develop the framework, what's their goal. So you should have a detailed look at the project. Who are the committers? So who is developing that? How diverse is the community? And what's their activity? Is it a project where the last commit is 5 years ago? Or is there a continuous maintenance? Same, you can check in the newsgroup. Newsgroup is the place to ask questions. And there you can actually see whether there are other people using the framework too. Or are you the only one? And finally, you should definitely understand the stakeholder of a project. That basically means you should understand why another company develops this framework, because this is important to judge whether they will continue to do that or whether they will just stop. So for example, if it's, let's say, an individual developer, and this was maybe a master thesis, then this developer might not continue after the master thesis, while if it's a big company, and for example, the company makes money with it, they probably continue to do that until they, or as long as they make money with it. So get in contact with them. And do not expect anything to happen without your influence. That means if you use a framework and it has a bug in it, the first thing that you should do is report it, and hopefully people maintaining the project will fix it for you, but you cannot rely on that. So you have to be aware of the chance that you yourself need to do something to fix the bug. That can either mean that you really fix it yourself. However, in most cases, a more simple choice would be to pay some consultant to actually do that for you, because most big projects have some companies providing those services. So that means be ready to invest in some support in training, sponsored development. So the cost that you save because you don't have to pay for licenses, you should be aware that you might spend some of those costs for services around open source. And that at the end of the day is the answer to the question, is it for free? Yes, you don't have to pay for any license, but you should be ready to pay some money for additional services or to fix something in the framework yourself. Okay, so that's my last slide. As mentioned on the first one, there are obviously much more questions around that, like how to manage dependencies, how to deal with versions, and so on. As mentioned or as promised, I have a textual version of this. You can find that here. So this is a very long document providing more details, especially about the more technical questions. And there are also links to some tutorials in this document. And if you have any specific questions, feel free to ask me right now or to get in contact with me. I also have placed some business cards over here in case you're interested. Okay, are there any questions right now? No. Okay, then I thank you for the attention and I free the stage for Tyler, who will talk about Eclipse-J. That was the framework I mentioned, the new Eclipse. Cool, thank you.